Greetings, my name is Luis Rivera, and this time we'll set up the following infrastructure in AWS using Terraform. It includes the following components: Amazon Route 53 record to access your application through DNS, a classic load balancer hosted in the public subnets, pointing to your EC2 instances managed by an autoscaling group. The EC2 instances are hosted in the private subnets, and we also have an Nginx server. Unfortunately, I could configure the EFS volume, so we'll omit it for now and work with the EVS volume for each EC2 instance. Next, we'll see the configuration of each component in Terraform. In your directory, you can see the modules and variables folder, as well the three files: main, provider.tf, and variables.tf. We'll omit the other files since Terraform will generate them automatically. In the modules folder, we have the following modules for your infrastructure: autoscaling group, EC2, which is a launch template, EFS module, load balancer, Route 53, VPC. Each module has three files: main.tf, variables.tf, and outputs.tf. In the main provider.tf, we set your AWS provider, and the region will be working in the variables.tf. We'll define the project name, VPC module with CIDR, launch template module with the AMI data, and Route 53 module with the hosted zone ID. In the variables folder, this is a file name input.tf. Values contain the variables we'll use for your project. Project name, the name we want to give your project, VPC module, the CIDR for your VPC, LCAC2 module, information about the AMI for your EC2 instances in the launch template, Route 53 ID, the ID of your hosting zone. Now let's briefly explain the H module. Autoscaling group. We define the autoscaling group with parameters such as desired capacity 3, maximum size 5, and minimum size 3. We add the load balancer that connects to your autoscaling group, and in the launch template we specify the ID or your launch template along with VPC identifier. This mode depends on the launch template to be created. There are no outputs, and the variables received included project name, LCID, launch template ID, subnets, list of private subnets in your VPC, and elastic load balancer will create. In the VPC module, in this module we first create the VPC resource by the specified CIDR. Then we create both the public and private subnets using availability zones in your region. We create the internet gateway and NAT gateway to connect the private subnets to the internet. We also create routing tables for each public and private subnets and associate the subnets with their respective routing tables. The variables received include VPC CIDR and the outputs include VPC's ID, public subnets, list of public subnets, private subnets, a list of private subnets, and AC availability zones. In the load balancer, in this module we create a classic load balancer providing the security group and subnets I will use. We define the health check on port 80 and this timing along with the listener on port 80 using HTTP protocol. This module depends on subnets and security group. Variables included subnets and security group, and the output is the load balancer. After configure each the model row 53. In this model we create on row 53 configuration providing the hosted zone ID, name, type and record will be connected to. This model depends on load balancer. Variables and include row 53 hosted zone ID, is row 53 ID, and load balancer. There are no outputs. After configure each module, we return to main file. We can each module and pass the variables. We can invoke the modules in any order since Terraform knows their dependencies. We invoke the VPC module passing the original CDR variables. In the launch template module, we pass the variables and the VPC ID through the module. In the autoscaling group module, we pass its variables along with IFS and load balancer module. Variables. In the load balancer module, we pass it variables from the VPC and launch template modules. Finally, on the route 53 module, we pass it variables and load balancer from the module. To create the infrastructure, we run the following commands in the terminal. Terraform init initializes the configuration in your directory. Terraform plan show the resources will be created. The input TF values contains the variables, and Terraform apply builds your infrastructure to view has been created. We access to DNS provided by Route 53 and we can see your page is displayed. I hope this explanation helps you create this infrastructure. Thanks for watching.